Hello, everybody. In this lesson, we're going to begin our study of decimals, and we're going to start with lesson 3.1. And our topic today is thousandths. And basically, the question is how can you describe the relationship between two decimal place value positions? So, over the last 2 years, you've learned tenths and hundredths. So, in fifth grade, we're going to add to that and expand to the thousandths. So there's going to be a short little investigation activity. So you'll need color pencils, color pens, and a straight edge, something that you can make straight lines. Okay, so make sure you have those supplies. All right, so let's go ahead and look at the directions. Thousandths are smaller parts than hundredths. If 100th is divided into 10 equal parts, each part is 1,000th because we have 10 times 100. Okay, each of the 100 parts times 10 more parts would be 1,000. So we're going to use the model at the right to show tenths, hundredths, and thousandths. So part A, divide the larger square into 10 equal columns or rectangles. Shade one rectangle. What part of the whole is the shaded rectangle? Write that part as a decimal and a fraction. Okay, so if you use your straight edge, we're going to make 10 columns going down. So put your straight edge against the two marks at the top and bottom. All right. So after you've done that, we've had 10 sections, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a tenths model, and it wants us to shade in one of the rectangles. So choose a color and shade in one out of the 10 rectangles. So what decimal is that showing us? Well, that's showing us 1/10, right? And so we write 1/10 as 0.1. What does that look like as a fraction? 1/10. 1 out of 10 parts. Easy enough, right? All right, so now we're going to divide each of these 10 rectangles, into 10 squares. Okay, so this time we're going to go left to right. Okay, and so we have rows like that. All right, so now I've taken each of those tenths and split them into 10 more parts. Well, that's 10 times 10, right? 10 times 10 is 100. So let's shade in one of these equal squares. Okay. So of that, how much do I have shaded? If I'm only looking at this one square, well, that's 100ths. Okay, and hundredths are smaller than tenths. And so how do we write 1/100th as a fraction? Just 1 over 100. Okay, now we're going to take the enlarged hundredth square. Okay, so this is a hundredths, right? Each of these little squares is worth 1/100th. So we're going to divide that larger square into 10 equal columns or rectangles. So they give you a little mark at the bottom to help with your straight edge. Okay, so now if we were to do that for every single one of the 100 squares, it would be 100 times 10, right? So now we'd have 1,000. So if each 100 square is divided into 10 equal rectangles, how many parts will the model have? It's got to have 1,000 parts. Okay. Because it would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And 10 hundreds is 1,000. So use a third color to shade one rectangle of the enlarged hundredth square. What part of the whole is the shaded rectangle? Write that part as a decimal and as a fraction. So if we just shade one of those, okay, remember, each of these rectangles would be 1,000. Okay, if we take the hundredth square and broke it into 10 pieces each, there would be 1,000 of these rectangles throughout. So if you only color one of them, we would write that as 0.001. And the fraction would be 1 over 1,000. Okay, so simple as that. So 0.1 is in the tenths place. That means there's 10 equal parts. 0.01 is read as 1/100th, and each of the parts are hundredths. The 0 in this case is in the tenths place. The 1 is in the hundredths place. And in the last example, we have 1/1000ths, and the 1 is in the thousandths place, and the first 0 is in the tenths place, the second 0 is in the hundredths place. Okay, so let's move on to page 110 and let's do some more work with this. All right, so number 1, explain what each shaded part of your model in the investigate section shows. What fraction can you write that relates each shaded part to the next greater part? So the model shows 1/10th, 1/100th, and 1,000th. Shaded, right? So if we go back to here, we had 1/10th, because we only had 10 pieces when we first started. Then we had 1/100th, and then we took the 1/100ths and broke each of those into 10 more pieces, and that gave us 1,000ths. Now, what fraction can you write that relates each shaded part to the next greater shaded part? Well, each shaded part is 1/10th as much as the next larger shaded part. Okay, so let's go back to this and look. So before you even drew any column lines, we just had one large square, right? Well, when we broke it into 10 parts, then each section was 1/10 of the larger square. Okay, when we then broke it into hundredths, this little square is 10 times or 1/10 of a tenth. So a hundredth is 1/10 of a tenth. And then a thousandth would be 1/10 of a hundredth. We could also go the other way and say that hundredths are 10 times as much as a thousandth. Or we could say a tenth is 10 times as much as a hundredth. So it depends on which way we're going. All right, number 2. Identify and describe a part of your model that shows 1,000th. Explain how you know. So one shaded rectangle of the hundredth. One shaded rectangle of the 100th. That is divided into 10 equal parts. In other words, the expanded square, right? Our last step that we took and divided each of the little squares into 10 equal parts. That gave us thousandths. So that one shows 1,000th. I would have 10 times 100. Each of the 100 squares would be broken into 10 pieces, or 1,000 parts. Each of those parts is 1/1000th of the whole. Okay. All right, so let's make some connections and practice. So the relationship of a digit in different place value positions is the same with decimals as it is with whole numbers, right? So if I said you had a value of 1 and then I gave the next value as 10, well, the 10 is 10 times as much as the 1, right? Or we would say the 1 is 1/10 as much as 10. So here, if we have 0, okay, so we can use our understanding of place value patterns and a place value chart to write decimals that are 10 times as much or 1/10 of a decimal. So here we have a number written as 400ths. If we were to go 10 times as much as 400ths, well, 10 times as much, that would be 4/10ths. 1/10 of the hundredths. In other words, if we took the hundredths and split them into 10 more parts each, we would have thousandths. And so we would write 0.004. And if we took 1/10 of 400ths, and so it would still be 4,000ths in the last box. I didn't need that zero there. I was just supposed to say 4/10. 4/100. Okay. So we can't put the decimal point though. All right. So blank is 10 times as much as 4/100. So what's bigger? 4/100. What is 10 times bigger than 4/100? 4/10. What is 1/10 of 4/100? 4/1000. All right. Use the steps below to complete the table. So we'll keep practicing and you'll get the hang of this, I'm certain. Write the given decimal in a place value chart. So here we have 3/100. What would be 10 times bigger than 3/100? 3/10. 1/10 would be that means the decimal would actually be even smaller, right? It's going to be 0.003. Okay, 1/10. Well, if you had 10 times as much, that would be 1 whole. So we could say 1 or 1.0. What would be 1/10 as big as 1/10? Well, what's 10 times tenths? Hundredths. So 0.01. 7/100. 10 times as much would be 7/10. 1/10 of 7/100. 10 times 100 parts would be 1,000 parts. So 0.007. Right? So let's see. Do we notice any patterns in these? So if we started at 3/100 and we said 3 times as much, you notice that the decimal point moved one place to the right. Again, when we said 10 times as much, the decimal place moved one place to the right. 0.7, I'm sorry, 0.07. If you're doing 10 times as much, the decimal point would move one time to the left. When you took 1/10 as much, the decimal place went one place to the left. So we wound up with 0.003. In 0.1, if we take 1/10, we're left with 0.01. And in 0.07, if we took 1/10, it would go one place to the left, and we'd wind up with 0.007. So if you take a fractional part, or a tenth, 100th, 1,000th, you're going to be moving left with our decimal point. When you take 10 times as much, we're moving to the right. Okay? So 10 times, move to the right. 1/10, move to the left. All right, so write the decimal shown by the shaded parts of each model. Okay, so we have 10, 20, 30, 40, 50, 60, 60 complete out of 100, right? And then they're saying this last square is broken into 10 pieces. So that's 1,000th, right? And there's 2, 4, 5 out of those 10 parts shaded. But that would be 1,000ths. So we have how many tenths? We have 1, 2, 3, 4, 5, 6. If we only had the columns, right, we would have 6 columns. Then if we go to the hundredth squares, that's the littler ones, right? These, we'd have 60 of those. Okay. And then 5/1000ths. Okay, let's look at number 2. So 10, 20, 30. Okay, so we're going to have 39. And how many are shaded in the thousandths place? Well, we have 8 out of the 10. So 3.98. Okay, number 3. We have 10, 11, 12, 13, 14, 15, 16, 17, 18 hundredths right now shaded. And in this very last one, there's 1/1000th. So 0.181 is what's shown by this model. In this last one, we have 99 hundredths shaded and nothing in the last row. So we could say 0.99 or 0.990 because there aren't any thousandths. All right, so now let's complete this sentence. 6/10 is 10 times as much as. So that means they're saying that the 6/10 is bigger than what? 10 times bigger than what? Well, it's 10 times bigger than 0.6. Number 7, 0.007 is 1/10 of what larger value? 7 hundredths. Eight thousandths is 1/10 of 0.8. 0.08, 8 hundredths. 5/10 is 10 times as much as what? So that means we'd have to move it to the right. And so it would be 50 hundredths is basically 10 times smaller than 5/10. Number 9. Okay, 10 times as much. We're starting with 2/10. 10 times as much as 2/10. That's just 2. 1/10 of 2 would move the decimal point one place to the left. 0.07, 10 times as much. Move the decimal point one place to the right, and we would have 0.7. 7/10 is 10 times as much as 0.7. 0.7. I said 0.7. 7/10 is 10 times as much as 7 hundredths. 1/10, we're going to move the decimal point to the left, and we have 7 thousandths. 5 hundredths, what is 10 times as much as 5 hundredths? 5/10. How much is 1/10 of 5 hundredths? 5 thousandths. What is 10 times as much as 4/10? 4. What is 1/10 as much as 4/10? 4 hundredths. 13. If we have 6 hundredths, 10 times as much as 6 hundredths, 6/10. 10 times as much as 9/10. 9. 10 times as much as 3/10. 3. 10 times as much as 8/100. 8/10. Okay, 1/10 of 6/100 would be thousandths. So 6/1000ths. 1/10 of 9/10 would be 9/100ths. 1/10 of 3/10 would be 3/100ths. And 1/10 of 8/100ths would be thousandths. So 0.008. Let's look at 17. All right, use the table for 17 and 20. Okay, so we have bee length in meters, and we have the bumblebee is 19,000th meter. The carpenter bee is 25 thousandths. The leaf cutting bee is 14 thousandths. The orchid bee is 28 thousandth. And the sweat bee is 6 thousandths of a meter. All right, so a science teacher showed an image of a carpenter bee on a wall. The image is 10 times as large as the actual bee. Then he showed another image of the bee that is 10 times as large as the first image. What is the length of the bee in the second image? So let's go to the carpenter bee. And we have 0.025, right? 0.025. And it says the first image is 10 times as large. So if we have our decimal, 0.025, and we want to be 10 times as large, that means we'd have 0.25. So instead of thousandths, we would be in the hundredths because we're 10 times as large as the thousandths. Then he showed another image of the bee that is 10 times as large as the first image. So then it even got bigger. Okay, 10 times as large. What's 10 times as much as 25 hundredths? Would be 2.5. Okay, because 10 times 2/10 would be 2. 5/100ths times 10 would be 5/10. So 2.5. So what's our question? What is the length of the bee in the second image? 2.5 meters. Okay. All right, now, number 18. Explain how you can use place value to describe how 5/100ths and 5,000ths compare. Okay, so what is that number? Well, that's read as 5/100ths. There's 100 parts. Okay, there's 5 out of the 100 parts. While 0.005 is 5,000ths. So the 5/100ths is 10 times larger. So Okay, so the number 0.05 is 5/100ths, while 0.005 is 5,000ths. So 5/100ths is 10 times as much as 5,000ths. Or we can go the other way and say 5,000ths is 1/10 of 5/100ths. All right, number 19. Terry, Sasha, and Harry each chose a number. Terry's number is 10 times as much as Sasha's. Harry's number is 1/10 of Sasha's. Sasha's number is 0.4. Okay, so 0.4, and we're going to say 10 times as much and 1/10 of. Okay, so what number did each person choose? Well, we know Sasha's is 0.4. 10 times as much as her would be 4. 1/10 as much would be 4/100ths. So we would say Sasha chose 4/10. Terry chose 4. And Harry chose 4/100ths. All right, number 20. An atlas beetle is about 14/100ths of a meter long. How does the length of the atlas beetle compare to the length of the leaf-cutting bee? All right, so the atlas beetle is 0.14. The leaf-cutting bee is 0.014. Well, this one's 14/100ths, and this one is 14,000ths. So the atlas bee is bigger by how much? 10 times. An atlas bee is 10 times as much as a leafcutter bee. All right, and the last one, 21. Choose the numbers that make the statement true. 65/100ths is 10 times as much as. So what would be smaller than that? Thousandths. So 0.065. But 0.6500ths is 1/10 of what? 6.5. Okay. All right, so that's it for our first lesson in chapter 3. In the next lesson, we'll continue to work on place value of decimals. So until then, I will see you soon.